Hello. Hey, is the password if then else?
Professor,
Yeah.
I sent you a message in Canvas Friday to see if you could look over my project submission. Should I just ask a grader, or are you still getting around to answering some of those?
I thought I'd looked at all of those, so yeah, let me take a look.
Okay.
Who was that, by the way, so I can jot your name down?
Jared Heron.
Okay.
Okay, thank you.
Okay. Well, this is going to get long. long. All right, so we're doing the selection and repetition. I put a question section at the end of every module, so if you have questions, you can ask them there. And all we're going to do today is walk through the code. We walked through the basics of if then else previously in the Java form. If then else is if, and then inside parentheses your Boolean test, open curly bracket, true branch, close curly bracket, else, open curly bracket, false branch, close curly bracket. So as always in Java, curly brackets are telling us sections of code, loops. The key thing to remember, you need a start condition, stop condition, and progress. And in the for loop, it's built right in. So it's start condition, semicolon, stop condition, semicolon, progress. The semicolons are important. If you accidentally type a comma, which I've done many times, you get the error conditions. So it's for, and then inside parentheses, start condition, semicolon, stop condition, semicolon, progress, open curly bracket, whatever you need inside of your loop, close curly bracket. So today I just want to walk through some code. And this code, I tried to come up with a good usage for the code that, that would actually need these things in a meaningful way. And finally, I just gave up and I just did this absolutely ridiculous amount of code. And I'm still trying to orient you towards object-oriented programming paradigm. So I did it in terms of a examples file and then a controller that controls the examples. So these selection repetition examples file, I made that a class, so public class selection repetition examples. And then there's no attributes here, right? I don't have any attributes. I just jump right into the methods. And one method is just demonstrating the if then else. And one method is demonstrating that it's if then else if. And what else do I have here? One is doing a for loop and one is doing a while loop. The last thing is the switch statement, and that's over here in the controller. So let's talk about how objects work and how if then else works. All these methods are public. Notice none of them are static. So what does that mean? It means I cannot use them until I build an object of that class. And again, the only method you should have static in your software is a main method. This object has no main method. That's legal, that's allowed. So all that's happening here is my selection repetition examples controller has a main method, public static void main string args. And inside there, I set up two, let's see, are these attributes or variables?
Variables.
Because they're inside of a method, right? Right. So I set up two variables, and then I need to get input from the user. So I've imported my scanner, just like we did in the other previous example, and I believe in your homework. And I create the scanner. How do I know when I get a new object? What do I look for to make sure I know that I've actually created an object?
New.
New, right. New means exactly what you think. I got a new thing. I got a new scanner here. And then if I'm going to use this selection repetition examples class, I need to create an object of that also. And I gave it the clever name OBJ, short for object. And there it is. This is its type. Its type is selection repetition examples. That's the name of the class. Its name is object, and it is a new selection repetition examples. That selection repetition examples with the parentheses, that is called the constructor method. You get that for free every time you build a class. Java will create the constructor for you. You don't need to build it. There will be times in the future, and we'll talk about that, where you will want to build it because you need it to do particular things. All right, so we have a new object of that class, and because it's a useless object, I just call it OBJ. Sometimes in examples, if I have to do two objects, I'll call one OBJ1 and OBJ2. Then I ask the user to give me an integer value. Assign it to integer value. I ask the user to give me a selector integer between 1 and 4. And basically, if you look here, I've created 4 different methods: the if then else, the if then else if, the simple for loop, and the simple while loop. There's 4 different methods. So what I'm doing here is I'm going to run one of those 4 methods based on the number that was given, 1 through 4. Does it have any useful value? No. I mean, this is just a ridiculous way to show off how to program these structures. That's it. It also gave me an opportunity to show you how the switch statement is built. So the switch statement is depending on that selector integer. And I called it a selector integer because it selects which part of the examples we're going to run. And if it's case 1, in other words, if the selector integer equals 1, I'm going to run the simple if then else method inside of the object. And it's dot notation. If it's not comfortable to you yet, will be comfortable in about 2 weeks. It's one of those, how did I ever not know that things? So literally this is saying, hey, inside this object, there's something called the simple if then else method. And I need you to run that method, object dot simple if then else. And then that particular one is defined where it needs some input. So that's what integer value is for. If the selector has the value of 2, then I run this. If the selector is 3, I run this. Oh, I guess I should have done that. Oh, yeah, okay. I'm saying what we did. Calculate the sum of the first integers using a for loop. And if it's 4, I do this. And notice after I'm done doing something, I break. Now here's why I break. If I get rid of the break and I do case 1 and I don't have a break, I'm going to get case 1 and case 2. If I don't have any breaks at all and selector integer is equal to 1, I'm going to get case 1 and then it'll fall through to case 2 and then it'll fall through to case 3 and fall through to case 4. If you want that, don't put the breaks in. But you're going to want that like 95% of the time. No, that's not an official number. A large percentage of the time. And then I included a default. Now we know, right? We told the user to give us a number between 1 and 4. So we know the only possible values are between 1 and 4. Why would I need a default? You always put a default in no matter what. So if the software doesn't behave the way you think it should, your program doesn't just go kablooey on you. You always want to control your software. Keep your program in a controlled state. That is both a program robustness issue and it is a cybersecurity issue. So basically, if I get a bad user who puts in a 5, then I can tell them that they screwed up. I put the setters and getters tag in here, but I don't have any setters and getters. Why? I don't have any attributes. Remember, for every attribute, you should have a setter and getter. I don't have any attributes. So this is what a switch case looks like, a switch statement looks like. Keyword switch, inside parentheses, almost always it's going to be just a variable or an attribute that you're switching on, and that variable and attribute can only take on a few specific values, and then you put the values in case the value is equal to 1, the value is equal to 2, the value is equal to 3. Unfortunately, the way this is, it looks like I'm saying it's case 1, case 2, case 3, case 4, as in it's just the first case, the second case, the third. It's not. Those are the values that selector integer can take on. Maybe I should have made it between 10 and 12, or 10 and 13, and then I could have had case 10, case 11, case 12, case 13. But that's what a switch statement looks like. I don't use them very often. It's one of those things that you don't need that often, but when you want them, boy, they are nice, because this is a lot cleaner than think of all the if then else statements you'd have to do and how ugly that would look if you didn't have the switch. All right, looking at just the basic if then else forms. I created a message, a string called message MSG. That's a very common naming convention. When I create that string, it's an empty string initially. And then all I do is I check, oh, okay, if they gave me a simple if then else. If, and then you put your Boolean test inside of parentheses. And in this case, again, this is completely arbitrary, guys. If the input's greater than 100, I'm going to print out, I'm going to make the message be numbers are too big, else numbers less than 100 are just fine. Completely artificial, but it shows you the if then else form. By the way, and then I return the message. Now a couple things about this method. It returns the message. The message is a string. That's why it says public. If you look here, this is called the signature. If you look here, public string, the name of the method, simple if then else, and then inside the parentheses, what do I need as input? I need as integer as input. Since it returns a string, I have to include the return type there. If it didn't return anything, its return type would be void. Remember, public static void main. Why is that void there? Because main doesn't return anything. If it doesn't return anything, I don't need a return statement. Why couldn't I have done this? Instead of message equals, I could have done that. I could have done that, right? Why is that bad? First of all, is it wrong? Will it compile and will it run? It should compile, it should run, and it should give you a string returned on every possible branch. Why is it bad? Any thoughts? How many of you guys have done that? It's okay to admit it. I've done it. I'll admit it. I've done that.
Is it because you're not clear what you're returning exactly?
Yes.
Instead of just a string, you don't label it.
Right. So there's a couple things that are going on here when you do it that way. Number one, you're unclear what you're returning. You didn't give it any kind of a good name. Message is like the minimal good name for a message. Okay. So you're not clear what you're returning. Number two, if you have a deeply nested or multiple if then else's, and you might have 4, 5, 6, 7 return statements if you go that route, and you want to change something, you might forget to put a return statement in one of the branches, and now you've got a method that you said was going to return a string and it doesn't. Not in all cases. Third, when people are reading your code, notice how I keep talking about that? When people are reading your code, it's harder for them to convince themselves that you returned the right thing all the time. And fourth, there is actually a lot of software that goes through your software or other people's software and analyzes it. And analyzing methods that have multiple return statements is a lot harder than analyzing a method that has a single return statement. All of your methods, you want to have one entry point. There's the entry point. And you want to have one exit point. There's the exit point. So every time you design something, try to design it where it has one entry point and one exit point. And with methods, it's easy. If they return anything, the entry point is right there in the parameters list, right next to the name. And then the entry point, the exit point should be exactly one return statement at the end of the method. And that means that you have to build temporary variables to hold the return value until you get to it. That is a better way to do programming. And so all this is, this string message, the only reason I created that is to hold the value until I'm ready to return it. Does that waste memory? A little bit, yeah. Do I care? No, no. We have so much memory these days compared to what we used to have. So that's the if then else. That's the if then else. If inside the parentheses, your Boolean test, open curly bracket, whatever you need to do, close curly bracket, else, open curly bracket, whatever you need to do, close curly bracket. You do not need that part, right? You can always have just a if this is true, do something, otherwise do nothing. And if you need to do nothing, just leave the else completely off. Leave the false branch and the else completely off. You can have this part empty, but never do it. Don't ever make your true branches empty. It's, again, hard for code understanding. All right, the else if is fairly simple also. I'm only giving you one example. Starts out the same. If here's your Boolean test, and now I let the Boolean test be equals. If the input is exactly equal to 0, then print out a message. And then else if it's greater than 0, else, and notice I don't have to put any more tests there. That's kind of my default condition, else. Now, if you're doing the logic here, you can see if it's equal to 0, I get an output, and if it's greater than 0, I get an output. So the only thing left in the else is if it's less than 0. And I do the same trick as I did before. Now, how many else ifs could I have had? As many as I wanted. Else if input is greater than 100, else if input is greater than 500, else if input is greater than 600, on and on and on. The sequencing in which you do those may matter. For example, if I said else if input is greater than 0, now let me put another one in here. Else if input is greater than 100, well, if it's greater than 0, if it's greater than 100, is it also greater than 0? Yes. So what's going to happen? I put in 500, and I'm going to get this message, because only that portion of the if then else if is what's going to execute. So if I needed to test for greater than 500 and greater than 0, I would just flip the order of that. I'd test for 500 first, and then I'd test for greater than 0. Those kinds of logical choices, they compile fine, they run fine, you get funky results and you're not sure why, then then we go back and say, okay, check your logic, make sure that you did this kind of stuff correctly. By the way, the best kind of errors to get are errors that don't compile right or errors that fail the execution. Those are usually relatively easy to fix. It's the ones where everything's working fine and the output isn't what it's supposed to be. That's the hard one to fix, because it means that your logic is wrong. Not just your coding, your logic is wrong. And coding is easier to fix than logic. Any questions about those two forms? And I hope, my belief, I'm operating under a belief that may be wrong. My belief is that you all have had some exposure to if then else and loops, whether it be MATLAB or C or C++ or Java or something in another class, or Python or something. So the idea of the if then else and loops, hopefully you're at least familiar with, even though it might have been a few years, right? You might be a little rusty, but you're more worried about the syntax than the purpose and the usage of these things. A simple for loop. Here we are. For, here's my starting condition, int I equal 1. Here's my stopping condition. Here's my progress. Those are the three things I need for a loop. And in the for loop, they're embedded right in the form of it. Starting condition, semicolon, stopping condition, semicolon, and then progress. And almost always your progress is going to be I++, just increment I by 1.
Is that stopping condition or continue addition?
It's a stopping condition that's always framed as a continuing condition. How's that for a confusing term? It's because we stop when that thing turns false. As long as that's true, you continue. But the point is, it tells you where the endpoint is. Now, a couple of things to think about with this. In loops, the way loops tend to get errors in them is either the first iteration of the loop or the last iteration of the loop. And usually what that means is the first iteration doesn't include something it should have, and the last iteration doesn't include something it should have. That's usually how mistakes are made in loops. So you do have to check your loop boundaries. For example, if I really wanted to, what I'm doing here is I'm just getting the sum of numbers. If I really want to get the sum of numbers, I would need to run some tests to make sure it's right. I would want to check this for an input of 0 to make sure that the sum of the first 0 numbers is 0. And if I did my loop wrong, my for loop wrong, I wouldn't get 0, I would get 1. And then I want to check other positive numbers, 3, 5, 10. Once you check basically 2 of them, check 1 and check another number, 15, then you can be confident that you're okay. You can check negative numbers too, and it's your choice as to what you want to do with them. This one sums the numbers. This one does the factorial, so it's instead of the result starts at 0, and the result is added, right? I is added because I'm doing the sum of numbers. Here I'm doing the factorial, so I'm getting the result times the number. And because if I started the result at 0, everything times 0 is 0, all of my factorials would be 0, so I have to start it at 1. Okay, so now same thing. I need 3 things: starting condition, stopping condition, and progress. Here's my starting condition. In a while loop, you have to set that up ahead of time. The only thing that's actually explicitly in the while loop is your stopping condition, which again is framed as a continuing, right? As long as upper limit is greater than 0, then keep going. And then you have to remember to put your progress in there. Now, this progress is very straightforward. That's why it's really, a for loop would be the more natural way to go here. But you have to put your progress in there. The progress in a while loop is generally not that straightforward. Generally, it's progress that occurs aperiodically or in fits and starts, and that's why it's a while loop. By the way, this does calculate the factorial. Instead of doing 1 times 2 times 3 times 4 times 5 times 6, I do it the other way around. I do it, 7 times 8 times 6 times 5 times 4 times 3. Since the sequence of multiplication doesn't matter, it still works out. So I just start with the upper limit and I count it down to, basically count it down to 0. So those are the forms. Those are the 4 forms that we're talking about today. And again, you can, I gave you this code. I hope I gave you this code. If I try to run just the class, selection, repetition, examples is that first class. It says, I cannot find main. Right, because remember in here, I didn't put a main. I put the main in the controller, which is normal for your program. Have main have main inside the controller. Now, from a design standpoint, would you ever put a main in here? And if so, why? Inside of this other class. What do you think? Yes or no? Yeah.
To use it for test cases, maybe?
Exactly. Yep, exactly. You can put a main in these classes and then run test cases from them. The way I would do it, by the way, I would have a separate method called test cases. So it's really clear that those are the test cases, and all main does is run the test cases. Main would build an object of that type and then run the test cases. That's the way I would do that. And that way you can test your classes without having to run things from scratch. And again, when you're running your test cases, you get to set the attribute values. You don't have to do this thing where it's like, as a user, I start the program and I put in a 5 and I put in a 12 and I put in a 16. You just set the attributes in the test case. No user input required. All right, so I said, okay, run that, and it said I can't because you didn't give me a main. So then I'll try to run the other one, the controller. And I'm calling it a controller for a reason that we'll talk about later in the semester. And it says, okay, input an integer value, put it in the 2, and it says that. Now, once you do this, just start running numbers. Uh-oh, this worked the other day. No, they never work on demo, worked the other day. I may have changed it since then. So just run stuff, right? Okay. But the main thing is, again, it's a ridiculous program. It doesn't do anything other than just show you the forms. Now, if you have questions about this, gosh, what can I do? What can I, can I do this? Can I do that? What's that called? Temp? Let me save it as temp. Yeah, I just saved that. Now I'll compile it. It compiled, and now I'll run it. It ran. How long did that take me? Less than 2 minutes? If you have questions about these, gosh, can I do this? Can I do that? Do it. Can I really have an empty if then else? Yeah, I sure can. Is that good? It's a great way to keep you up till 2 a.m. If it's in another class and you said, oh, I'll do that later, I'll just put the brackets in and do it later, and then you forgot, and then your program doesn't work right. You don't know why. So by all means, play with this stuff. If you haven't made and built your own simple if then else and for loop yet, I recommend that you take the 2 minutes that I just spent and do that. Okay? That's all we need to cover today. If you have questions, what a great time to ask them.
So in the homework, I know a few of us got some points taken off because we didn't have the system.out.print in the main file. Is there any other, I don't really know what you call it, formatting things like that that you would like us to follow? I mean, like there's the no empty true branches. Is there any other ones like that that we should know about when we're doing the homework?
Yeah, I'm not aware. So talk to the grader about that first and have the grader email me if you're not resolving it. I'd have to look and see what was taken off there.
Okay.
You can send me a message in Canvas about it too, and I can look at it on SpeedGrader in Canvas. And the grader, by the way, is Robert Apelian. Yeah, always bring lab questions to Dean first, homework questions to Robert Apelian first, and then if you can't resolve it through them, then they'll talk to me. Other questions? All right, guys. I'll see you Friday. We'll talk about project stuff. I'm going to talk about writing styles and get you prepped up for the second deliverable. Okay. And until then, have a great rest of your day, and we'll see you Friday.